Mark, you have been one of the first people to come out to Chile with the advanced team, and you have been instrumental in the site selection. And you're heading back tomorrow to take part in the RCC operations. But what would you say? How was these first few days and the site selection process?
Well, I think it's been a fantastic few days. It's been pretty intense, but I think it's also been very productive. We started with a tour of the Paranal area given by Professor Guillermo Chong here from the local university in Antofagasta, and that was really excellent because he got to show us a lot of candidate sites, potential sites around the area based on some of the requirements we had. We then took those set of candidate sites and essentially down selected to a couple of two or three that we thought might actually have a lot of potential. And then we followed that up with a more detailed survey, so that was both from the science perspective with Derek Pullen from the University of Leicester, and then more from an operations perspective from our side. And we tried to assess both the science richness of the sites and the actual operational practicality of the areas, and how representative they would be of a procedure for a mission like, for example, Mars, so ExoMars, for example.
So you're from Sykes,
Yes.
here with Andy, and we will hear more from Andy in the next few days. But can you quickly explain Sykes' his role in this project?
Yeah, sure. So we've got a role. Our role is mainly about software. So we're providing software on two sides of the safer coin, if you like. One side is on the rover itself. So that's where we're providing the autonomous navigation and localization software. So that more or less allows the rover to know where it is in the world and how to plan a path to some waypoints that are given by the team at the RCC. And it basically then controls Astraeus Bridget rover to do that. The other bit of software we have on the vehicle is the software which commands some of the instruments, allows that to be automated. So it tells, for example, Wisdom when to acquire samples and when to stop, and it also supports the traverses that are needed. Some particular patterns are needed to do certain types of Wisdom trajectories, and that's what that software also assists with. So that's on board the rover, and then off board the rover at the RCC we provide a tool called Overseer Interact, which is the main planning, monitoring, control piece of software, and that allows the operators first of all to review the data that comes back from the rover in a kind of an integrated way, so they can see both the navigation data from the rover in a synthetic 3D environment, but also the instrument data, so readings from Wisdom, the PanCam data, and also Clupy and so on. And then they can interact with the science team, who will then decide where they want to go and what kind of plan they want to execute, and they'll collectively come up with a plan which can be again created in this tool called Interact, and they will dispatch that plan back to the local centre here for a quick check, and then onward to the rover, and then the process begins again. And the process of actually the rover navigating is the piece that Andy will probably talk about a little later in your sequence.
Sounds great. I can't wait to see all this in action.
All right. Good.
Was there any personal experience in the past few days which
I guess the personal experience is got to be the sky. I mean, it's a simple one, but it's got to be the night sky.